All right, so we'll start with, are there any questions from the homework? Crickets. Okay, so I came up with this additional problem. Actually, this problem was in your book as a simulation. They're like, run a simulation on this. I think you'll see that running a simulation on this is a pain in the tuchus. I did it, but I didn't like it. But then I was like, oh, we can change this into a probability question. Because most things that you can simulate, not everything, but a lot of things that you can simulate, I should say, we can find the probability without having to do the simulation, and it takes way less time and way less work. Okay? So here's the question. It says, in theory, a golfer playing a par 4 hole tees off, hitting the ball into the fairway, then hits an approach shot onto the green. Then the first putt, usually long, won't go in. By the way, on yours it says put instead of putt because I didn't spell check. Well, I did spell check, but I didn't, check it until after I printed it. Usually long won't go in, but the second putt, usually much shorter, should. Sounds simple enough, but there are other ways to get 4 strokes as well. So we want to list all the ways that a golfer could put the ball in the hole in exactly 4 strokes. So one way that he could do that would be he hits the fairway on his first shot. Then he hits the green. But then what has to happen next if he's going to make it in 4 shots exactly? He's got to miss the putt, right? So I'm going to put not P. He misses the putt. But then he does get the putt on the next one. Another possibility is that he hits the fairway with his first shot, that he misses the green with his next shot, then he makes the green on the next shot, then he has to make his first putt. So what if he doesn't make the fairway with his first shot? So doesn't make the fairway, but then he does make the green. He doesn't make his first putt, but then he does make his second putt. And the last possibility that I can think of is that he doesn't hit the fairway, he doesn't hit the green, but then he does hit the green, and he makes his first putt.
Could he miss the fairway and then make the fairway and then make the green and then make the first putt?
They don't, so...
Is that not possible?
Yeah, so if you miss the fairway, you're aiming at the green then.
Okay.
But just from a disadvantageous position. It's a good question. And part of the reason I liked this question is because I was looking for questions for your final exam the other day, and there was one similar to this. It was simpler, but there was one very similar to this. And I was like, okay, that's a good question. So that's why I wanted to do it. Ian and I went over this last period. Can you think of any other way to do this in 4? I just can't think of anything. And I guess what we could do, there are 16 different possibilities with 4 shots. but most of them are not in the hole. I guess we could try to list all 16 possibilities.
We could. Do we want to?
I'll tell you what. Let's. Do I really want to do that? And are there really 16?
Probably not.
Think there's less?
I don't really know.
Well, that would be the most because it bifurcates each time. It doubles each time. All right. Well, if we're still stuck, we'll go back at the end and go, yeah, we'll work it out. So we want to find the probability that the golfer puts the ball in the hole in exactly 4 strokes using the following assumptions. First, that the tee shot, that's the first shot, lands in the fairway 70% of the time. So that this happens is 0.7. Which means that not fairway happens is the complement of that. That's 0.3. Then it says a first shot lands on the green 80% of the time from the fairway. So if you're on the fairway to get on the green, that's 80%. So if you're on the fairway, nope. So on the fairway, not on the green, then would be the complement of that would be 20%. But only 40% of the time otherwise. So if you're not on the fairway, but you get on the green, that's going to be 40% of the time. And if you're not on the fairway, then not on the green is 60% of the time. Subsequent approach shots land on the green 90% of the time. So this is going to be 0.9 to get to the green, and this is going to be 0.9. The first putt goes in 20% of the time. Both of these are first putts. So that's 0.2 and 0.2. And this would be 0.8 and 0.8 because 80% of the time it doesn't go in. And then it says subsequent putts go in 90% of the time. So this is 0.9 and this is 0.9. So yeah, at any point, if you're like, that doesn't make any sense, please stop me because, again, I'm missing 2.4% someplace in this. So the probability of getting 4 strokes, each of these is a mutually exclusive event, or this series of events is mutually exclusive to the other ones. You can't get the ball in 4 strokes this way and at the same time do it this way. So I got that the probability would be 0.7 times 0.8, because these are independent events, times 0.8 times 0.9, plus the next one to the right, 0.7 times 0.2 times 0.9 times 0.2 plus 0.3 times 0.4 times 0.8 times 0.9 plus 0.3 times 0.6 times 0.9 times 0.2. I'm going to check the numbers that I have on my piece of paper at the same time. 7889, 7292, 3489, 3692. Yep. And I got 0.5472 when I added all those together. All right, so Quinn got that too. So, all right. Okay. So here's where I'm having trouble. I think that that is correct. I'm pretty confident that that's correct.
Yeah.
Then in part C, it says, what's the probability that the golfer will have a number of strokes on the hole other than 4? Well, it's either 4 or it's not 4. So it should just be the complement. So I want this stuff up here. So I'm going to write for part C, it should be just 1 minus 0.5472, which is 0.4528. And here's where I got into trouble. I said, oh, verify that another way. Like you and I were talking about this morning, your question partly sparked this, me going, oh, let's do this. So what I did was I tried to come up with all of the ways that he didn't get it in 4. So what I did is I took all of these and said he missed the last putt. Right? So, and if he misses that putt, he can't make it in 4, so it doesn't matter. So that's all of these. Instead of 0.9 at the end, that's going to be 0.1 because it'll be the complement of that. And instead of 0.2 here, it'll be 0.8. So that's more than 4 if he's on the green. But there are other ways. And I don't know what that adds up to. Do you have a number for it already?
Yes, I got 0.284.
Say it again for me. 5 2 what?
0.2848.
0.2848. Thank you. Then I was like, okay, but there must be other ways that he doesn't get it in 4. So one way, because these two obviously, that's not close to this.
Yeah.
What are the other possibilities? So another possibility is that he hits the fairway and then he misses the green and then he misses the green again. If he does that, because in our scenario you have to putt to make the last shot, that's going to be more than 4. Another possibility is that he makes the fairway, assuming he doesn't make the fairway, and then he misses the green, and then he misses the green. And then the only other possibility I could come up with is that he made it in 3. He makes the fairway, he makes the green, he makes the putt. I can't come up with anything else other than those 3. I'm hoping that Morgan's not watching this going, oh, you idiot, you missed this one. So this, let's see, make the fairway 0.7. And from the fairway, miss the green 0.2. Oh, hang on a second. I'm going to just multiply those. And subsequent approach shots are supposed to go in 90% of the time. So missing the green again, you've only got a 0.1%. 0.1 is the probability there. So miss the fairway, 0.3. Miss the green after missing the fairway. Let's see, miss the fairway, miss the green, that's 0.6. And this is 0.1 again. And then fairway 0.7, hit the green 0.8, hit the putt 0.2. And I don't think that comes out to be 0.16 something. It's smaller than that. Ian, did you crank those already?
Which ones?
This bottom one.
No.
I got the 0.144.
0.1 what?
44.
144?
Yes.
It should be 3 decimal places, I think. Hang on a second. No, you're right. I think it is going to end in 0. Ian, did you get 0.144?
Yeah.
So when you add these two together, here and here, 428, 428 what? 8? And that's not quite the number that I'm supposed to get.
Yeah, it's not.
I'm 0.024 off. And it's driving me nuts. I can't think of what I have done incorrectly.
Yeah, I don't know.
Unless that, although the problem doesn't say it, the only thing I can think of is that there's the other possibility is that, like we were talking earlier, that from the fairway or not from the fairway, you could hit it directly into the hole.
Yeah.
It's the only thing I can think of, but although that's logically a possibility, I think this system says that doesn't ever happen. And here, if it's not on the green, well, it's obviously not in the hole. So these two, I guess that this number might,
You could make it more possible for 4 if that was a possibility.
So it would be more than 0.5472.
Yeah, because then you could do fairway, miss green, make it in.
Correct. Or,
Not fairway, miss green, and make it in as well.
right. So maybe that's where we're missing something.
Yeah.
I'll send it to Mr. Hedstrom. See what he thinks. It does, and part of the reason I wanted to go ahead and go over with you guys anyway is it points out something that if you have two events that should be complementary, they better add up to one or something's not right. So that's how I know something's not quite right. I don't know what it is, but something's not quite right. And, like I said, I think you can say, all right, on this hole, it's impossible to hit it into the hole until you hit it on the green. Okay. I think if that's the case, we've accounted for every possibility. All right. Well, we'll leave it. And if I get an answer over the break, I'll send it to you so you don't lose sleep. I'm sure you lay awake nights thinking about statistics problems.
Oh, yes.
I do sometimes. There are times when I do problems that it just goes round and round and round in my head. All right. Well, that's it then. So after we finished, Quinn found the thing that I had missed. Right down here, you could have not on the fairway, but then on the green, and then make the putt. You can make it in 3 that way. So, bye, Ian.
Bye.
So not on the fairway, on the green, make the putt. So not on the fairway is 0.3.
No, it's percentage. Yeah, 0.3.
Point what? 0.3.
Yes, 0.3.
And then on the green from there is 0.4. Let me double check that. So only 40% right. And the chances of making your first putt are 20%,
It's 0.2.
right? So that is 0.12. What does that come out to be? 0.024? Yes.
Yes.
So then that, when we add that into this, makes this, if I add 0.24 to this, 0.024, it ends up being 0.428, 4528. Exactly. So I missed this as a possibility for getting 3. I only thought of the simplest way to get 3 is on the fairway, on the green, make the putt. But you could also miss the fairway, but then hit the green, make the putt.
Yes, because I compared with the part A, and then I found out that we lost one more case.
Gotcha. Huzzah. Thank you very much.